All right, guys. Well, the midterm is over, so I'm going to select a few topics to cover before I take my leave. I'm happy to report to you that the substitute has, have been found. There are, 2 substitutes to cover my 2 classes, and the one for you and the one for the other class. And these instructors are going to be doing live lectures, so you can still, log in the same way you log in Zoom and getting, having the lectures starting on Wednesday. And you will be in good hands. But prior to that, there are a couple of things I like to cover as much as possible. Then one of the things I like to cover, which I think you will immediately need, is for the use of absolute value function. Okay, so that's one thing I will cover today. And the other thing I will cover today is we talk about the composition of function. So I'm going to also cover what is decomposition, right? So there's a composition, there's a decomposition. The use of decomposition function, decomposing function, that's also going to be something you need for a calculus class, especially for chain rule. So that's the second thing we're going to cover if we can do it. I think we can. The third thing I would like to cover is we're going to cover the solving of inequalities, and I'll give you some ideas about solving these inequalities as they are related to mathematical principles. So our goal, once again, is to understand the methods as they are related to mathematical principles, which I emphasize so much, from the beginning. So first thing first, right? To cover these topics, I will take you guys to basic 51A. Okay, basic 51A. Okay, it should be, it's over 100 pages. I would say probably 120-ish something, some pages. I don't have the latest version of the of my own handout. I have the old version. I have the electronic form, and so if you, I will ask you guys to find it. Okay, those exercises you can see, even though my exercises in the notes are scattered all over the places, but I do have, if I teach, well, as I'm teaching the class, I do have an agenda as what they're for. And because of my medical leave, so I'm going to bring this forward. And I think it will be most fitting to, this is on page 129. I found it on page 129 of your notes. Okay. This is about how we apply the absolute value function, the absolute value function, right? We understand, I address these issues about the meaning, right? We spend a lot of time. This is the third time we cover it, right? The first time we cover it, it's under the concept of function. And the second, we did the graph and we did the intercepts, and we have covered the narrative, right? The narrative is the absolute value of a non-negative number is the same as the number. And the absolute value of a negative number is its opposite. I hope that through these practices that you guys are gonna totally, fully master these ideas and the narratives to have a better understanding of it. And you're gonna use it in Calc 1 and Calc 2. And see the absolute value of a non-negative number if x is greater than or equal to 0, right? It has great applications, which you're gonna use, right? If the absolute value of a non-negative number is asked for, and we know the number is non-negative, then the absolute value of a non-negative number is the same as the number, If the absolute value of a negative number, right, if x is negative, and it's opposite. All of this to ensure the absolute value of any number is at least 0, right? So of course we understand that one sentence domain and range, right? This is greater than or equal to 0. We understand all of these facts, and last week we covered solving inequalities equations involve absolute value. Okay, those are, really are the places that you gain. I see a lot of students get points and lose points easily. Now, with that in mind, right, we understand this expression, right? So when we look at 51A, right, how do we handle cases like that, right? The title of this one is Rewrite Functions. Okay. Rewrite functions as a piecewise function. Okay. This is one function, and this is a piecewise function. There are two pieces. You see, there's two pieces, right? On the graph, right? On the graph, we clearly see two pieces. So this kind of function is called piecewise function. Piecewise function, two pieces. Each piece is a different function. Each piece is a different function. They have their own specific domain and range. They have their specific domain and range. Okay, so here, let me bring this up. So all of these we have done before, right? Piecewise function, right? Piecewise function. Sometimes a function may have 3 pieces, 5 pieces, 10 pieces, but the situation you guys are going to deal with are typically 2 pieces or 3 pieces at most. Okay. Why we need to write them as 2 pieces? Because in the study of a calculus concept, sometimes you need to look at the behavior of the function from the left, or sometimes you'll need to look at the behavior of the function from the right. From left is smaller, right is larger. So you're going to look at the behavior from two sides. For that reason, we want to be able to, to write these 2 pieces algebraically. And the goal is to get rid of the absolute value sign. Therefore, we can process the required algebraic expression in order to simplify. So with that said and done, right? So when we look at the function, which is the absolute value of x plus 2, how do we make this into 2 pieces? Right? How do we make this into 2 pieces? We know the domain is all real numbers, and the range is x plus 2 is at least greater than equal to at least 0. So there's no change. But how can we make that into 2 pieces? And this is how you can do it algebraically. Okay, this is how we can do it algebraically. So when we see this form, we need to understand x is just a placeholder. X is just a placeholder. Okay, so if we replace x by anything, right, then if that anything is at least 0, the absolute value of anything will be the same as anything. The absolute value of a negative, whatever that anything is, right? If the anything is negative, and then the absolute value of anything is negative of anything, the opposite. So you can see these symbolic operations, and the placeholder concept is permeated throughout mathematics. Okay, symbolic operations. So in the case it is x, right? In the case it's x, then you can view x as a single number, but you can also view x as, something can be as complicated as it can be. And in our situation, anything is x plus 2. So if you consider anything is x plus 2, and you can just copy and paste this guy, right? So when this is x plus 2, and omega is x plus 2, so when x plus 2 is positive or 0, the absolute value of x plus 2 is the same as x plus 2, or omega. And the absolute value of x plus 2 is, if x plus 2 is negative, if x plus 2 is negative, then the absolute value of omega is the opposite of it. So that's how you can operate to break the absolute value into 2 pieces. And then we will add another step. Okay, this one more step would be to solve these 2 inequalities. Okay, solving this inequality meaning we're gonna subtract 2 on both sides. So we have x greater than or equals to -2. And solving this inequality, we're gonna solve by subtracting 2 on both sides. So this is gonna be x less than -2. Does that make sense to you guys? So this is the model. This is the model for us to break the absolute value into 2 pieces. Okay, so in the case of x plus 2, right, you can break that into 2 pieces. Once you can break them into 2 pieces, and you will be able to carry out the operations that needed for your next steps, that you're going to encounter those similar situations in calculus courses, Okay, so let's look at another application, right? Let's look at another application. For example, I'm going to take another one, 7, right? Number 7, further application, right? Further application. Over here, I have a g of x, right, equals to the absolute value of x plus 2 and divided by x plus 2. Look at that, right? So we have absolute value of x plus 2 over x plus 2. And in this case, of course, we need to consider the fact that this function's domain has to be considered. The domain, we need to ensure that x plus 2 cannot be 0. And as a result, x cannot be, right? X cannot be -2. So we are aware of the domain. So when we're making these into 2 pieces, right? Knowing x plus 2, for absolute value of x plus 2, we already got this 2 pieces, right? We already have this pieces, 2 pieces. So we can use this pieces we already got, right? We can use this piece in order to write 2 pieces for g. And what will be that 2 pieces for g? There will be 2 pieces, right? Because there are 2 cases. There are 2 cases for g. And one case will be x greater than or equals to -2. And the other piece, it will be, x is greater than, is less than -2. And on this piece, when I take absolute value of x plus 2, right? The same formula. In that case, the absolute value of x plus 2 is the same as x plus 2. So I'm going to take that piece to replace it as the first case is fitting. But be careful. not equals to -2. -2 cannot be in the domain. So here, when I process this new function g, I have to make sure the domain is considered. The domain is considered. Okay. In the latter case, when x is less than -2, the absolute value of x plus 2 is going to be the opposite of a negative, the opposite of x plus 2, which is a negative x plus 2, right? You can see that's how we formulate the two pieces. And then afterwards, okay, all we have to do is just simplify. Right, x plus 2 divided by x plus 2, that's a 1. Negative of x plus 2 divided by x plus 2, that's going to be a -1. So by this time, g of x is now simplified into two pieces. And then you can, this will typically be an intermediate step. In the process, you're handling your calculus concept. Okay, so would you like to practice some? Yes? So how about you guys try number 3? How about you guys try number 3? You know the process we dealt with what we worked through these these function expressions, right? How we can write 1 into 2 pieces as needed, right? So would you like to try number 3? Number 3, you're asked to reduce h of x equals to the absolute value of x over x. Can you make this into 2 pieces? A couple minutes, maybe give you 5 minutes to try this. Piecewise function. When the absolute value of x is present, there's nothing you can do. Okay, by the way, you cannot reduce the x. You cannot say, I'm going to cross out the x. No, you cannot. You have to, because for absolute value, right? For absolute value, when you have a times b, that's equals, you can separate you can separate these. Okay, you can separate, one is a multiplication, you can take the absolute value separately, or you can, when you have a quotient, you can do this, right? A over b. Absolute value of a over absolute value of b. That's all you can do. You cannot do addition, subtraction. When a number is inside the absolute value, when you want to take them out, you either know the sign. If you don't know the sign, you have to bring them into pieces. That's just the nature of this function. Right? Think of the narrative. Think of the narrative. Think of that. Right? Think of that.
Professor?
Yes.
Can we have breakout room?
Sure. You guys want to have breakout rooms? I'm going to give you a couple minutes. Go for it if you want.
Thank you.
It's open. Be aware of domain. Be aware of domain. In your mind, I wish you guys to, I don't think it's reciting the words is that important. Is to speak the language with your own understanding in it, right? You don't have to recite the word for word, but you need to understand the absolute value of a non-negative number is the same as a number, which what the first sentence says, the first branch says. And the absolute value of a negative number is its opposite. It's opposite, right? Because x itself is negative, so the absolute value of it is going to be the opposite of the negative. So it's going to be guaranteed a positive, right? So we also understand these facts, right? The absolute value of x, which we have addressed this in the homework, in the lectures we talked about last week, right? Solving inequalities of various kind. All of these, in particular, this inequality, this, absolute truth, this is the absolute truth. It's often used. So we need to truly understand it. Okay, if you simply just recite the word and cannot apply, that doesn't help you very much. The domain should be x cannot be 0, right? So when we use the two branches, then we will not need to use when x equals to 0 case, right? So you'll be using x just greater than 0 case. Okay, so we need to be very careful, right? We need to be very careful, even though this is true for x is greater than or equal to 0, but we only use part of it. We only use part of it. So now if we proceed with this, if we proceed with that, right? With all these understandings, you can put these in your think out aloud, right? And you will have two branches. You have two branches. One of the branch would be if x is larger than 0. And the other case, of course, is if x is less than 0. When x is larger than 0, the expressions are the same. But when x is larger than 0, the absolute value of positive number is the same as the number. So this becomes x. When x is negative, the absolute value of negative number is negative x. So in the end, I'm just, I think I'm going to close the room. It shouldn't take that long. Okay. So in the end, you're going to get all of these, right? So this is equals to 1, and that equals to -1. Okay. This function is going to show up in your calculus test. Okay. I'm going to have you, all right, let's wait for them to come back and then we wrap this up, right? So at the heart of this, at the heart of all of these processes is really about these two sentences. It's really about these two sentences. Okay, these two sentences, you can see, this is the third time we cover absolute value. Okay, the first time we cover absolute value, it was at a, way back, right? We cover absolute value as a function, absolute value function, and we talk about the domain, range, intercept as all of, its related properties. Okay, and the second case, the second time we cover it, it was last week. Last week, we apply it to solve the if statement. And today we are applying it in real situation, which you're going to use in calculus classes. All of these exercises I have here, 51A and 51 and 51B, these are the exercises are not my own creations. They are from your calculus textbook. We're just not handling calculus concept. We're just handling at the basic level as how to deal with one of the steps, one of the algebraic steps you will need to understand in your calculus class. Okay, so let me give you some time so you guys can try number 4 and number 6. How about that? Number 4, number 6. How about, are you ready? Number 4 and number 6. Number 4, you have f of x equals to the absolute value of x minus 3. And you're going to make it into 2 pieces. You're going to make it into 2 pieces. And number 6, right? You're going to have a little bit more complicated. This question is, all of these questions are from your calculus text. Okay, I'm not that creative, right? I'm just a copycat. I took it out of the context of calculus and look at the basic algebraic skills required to handle them. And you may well encounter other examples of similar nature on exams when other professors are teaching these courses. Bruce, you think 5 minutes will be sufficient?
Probably so, Professor.
Okay, let's do it again. Open all rooms. If you have any questions, please don't hesitate. Okay, please don't hesitate to come to me. Okay, I'm just going to get something to drink. I just refill my cup. I'll be right back. How's it going, guys? Is it about time? All right, guys, welcome back. Farouz, did I give you enough time or you guys didn't have enough time? Okay, still 5 seconds. All right, guys. Thank you, Farouz. I saw you. I saw
Yes.
I saw you have finished number 4, right? You probably didn't finish number 6.
That's right.
Okay, but that's fine. That's fine because I'm gonna try to speed up a little bit because I feel like I'll try to cover these are the materials. I want you guys to understand these materials is not very likely that you will be tested in this semester, but you definitively need them for your success in your next course. Okay. So about these, because you actually don't see many of such exercises in the pre-calculus textbook. Am I right, Farouz? Because I don't see very many. I bring these questions purely from my college, my calculus teaching experience. When typically at the beginning of semester of calculus, when we have a limited amount of time to do the review, and I found most of my students didn't seem to have seen this, and the consequence is severe. The consequence is severe. The consequence is severe in such a way that the students, if they get what I did in that brief time of review, they're struggling, even if they got it, right? For those students who didn't get it during that brief time of review, and they will have a hard time and they easily lose 10, 20 points on the first exam and lose some points on the final exam. Okay, so this is how serious it is that you try. So I expect you guys, even after all this is done, you could come back, or you can take these questions to ask your other instructors, but you need to come back. You need to be exposed to these ideas and you need to practice. You need to practice, like Farouz said. You need to do it over and over again so that you gain understanding and then you gain freedom. Okay, so for example, in this case, right? Omega is x minus 3. That's x minus 3, right? So algebraically, so this is x minus 3. So when x minus 3 is negative, the absolute value of is going to be negative of x minus 3. So it's just a simple algebraic substitution. Do you guys see that? Okay. And then it's just a matter of simplify or solving the 2 if statement. Okay, x minus 3 is greater than equals to 0. That means x is greater than equals to 3. X minus 3 is less than 0. That means x is less than 3. Then you're done. And you need these 2 pieces. And for the second expression, whether you write it as minus x plus 3 or you write it this way, it doesn't really matter. It really doesn't matter algebraically. But if you want to know, then these 2 you can use interchangeably. Yes, Farouz?
Professor, do we consider the x cannot be equal 3?
Not in this case, not in number 4. Because the function you're dealing with is absolute value of x minus 3. The domain is all real numbers.
I see. It is not a rational expression or rational function.
It is not a rational. It is not.
That's right.
It isn't. There's no denominator. There's no denominator. If there is a denominator, like in the next case, right? Because you will typically be concerned about the domain. In this case, the domain is from negative infinity to positive infinity. Right, so you have to see the function you have at hand, right? Yeah. When do I need to consider that denominator, right? Well, they have the denominator. Denominator cannot be 0. That's how we drop the equal case, right?
Yes.
And in the other case is that you have a denominator x plus 2. So from the outset, the domain cannot include a negative 2, right? So you have to look at the function you have at hand.
The reason I asked, because in the breakout room, I mentioned it. So I want to correct my typo. We do that domain consideration only when we have denominator, when we have absolute value in the denominator.
Right. You know, you will have, you know, in this semester, I haven't get a chance to cover domain. If I have, I will cover. If otherwise, your other instructor will cover those. Domain is a big trunk, and I actually prepared exercise for you. I may not have time to do it, but I think I might have some tomorrow. But who knows? But anybody who covered this, they're going to cover this very well. Is that you need to know the domain and range of all the basic functions. That's the beginning. Okay, remember all the basic functions, we have considered domain and range for each one of them. We did the graph and everything, right? That's the very foundation. With that foundation, you can pretty much deal with any domain range issues. And of course, you're going to end up with inequalities, and then you solve those inequalities. And sometimes you're going to encounter different kinds of inequalities. Sometimes you may encounter, like in these situations, right? These are considered pretty simple situations. You may encounter trig functions in your inequality solving. You may encounter exponential function, log function in your, in your problem, in your questions. So all of these are possible, okay? And you will get to see those from those exercises, and you go through the pages of the notes, right? And these functions I have selected here, they are exactly the same question from your calculus textbook. I'm not exaggerating. I'm not creating new questions for you. This is your calculus textbook. Do you guys see that? Okay, they're from that textbook. Okay, I just take them out as I see that pre-calculus pre-calculus can include these materials, it would be most beneficial for our student because you have a little advantage. Okay, so by the time you see that, when you see your calculus textbook having these questions, you already see this the second time. You'll see it then the second time. But anyway, without further ado, so in this situation, you're going to have to handle a number of situations. Okay, that's why I feel like it would take too long for we do it in the dark, right? Where Farouz can do it, but it's just like, I just want to bring you guys together, and I don't think I can give you a lot of time. Feel free to go to Farouz's office hours. I think he's going to announce. He always announces those office hours. So without further ado, so first you want to handle x plus 2 in the absolute value. And also you have these domain consideration, right? So in this case, domain cannot be 0, denominator cannot be 0. So as a result, x cannot be -2, right? And then let's look at the x plus 2, the absolute value, x plus 2, right? The absolute value of x plus 2, right? So we come back to that narrative I wrote down here. When you study mathematics, you want to be able to verbalize it with your understanding, so you can explain to someone else. By the time you can explain to someone else, you already understand more than that someone else that you explain to. Do you understand what I meant? Okay. So these practices are necessary for your success, especially if you want to go through the calculus classes. You can't just sit there and just expect yourself you can handle it. You need some study groups. You need to help each other, and also share the understanding, helping each other, correcting each other through language and the work you put on paper, right? So this is a part of the effort in that direction. And so I hope to give you some help. So in this case, our omega is x plus 2, right? So you see x plus 2 as one entity. We already did x plus 2, right? So x plus 2, if the absolute value is, we already did this one, right? So we're doing this again. So this is for x plus 2. But as you work through this, the words, the words I use, I don't know about you, the words I use, I sounding those words in my head is really these two sentences. I don't know if you have any other sentences to go through. You certainly can. English is most likely your first language. Your English is better than mine. So however you speak it, you speak that. Okay, so this is x larger than -2, and this is x is smaller than -2, right? But this is going to be in the denominator. So when you work with f of x, right? When you work with the f of x, and you are going to have two branches. If that, but here x cannot be -2. So here you need to remove that. You just use part of this. You use part of this. Do you guys follow me? This case is complete, but when you apply it, you will have to use part of it because of domain consideration. Do you guys see that? In other words, every little details you work with, you need to consider when you do the kind of math you're doing in calculus. If you overlook here, there, that's where you're going to lose points. You guys understand what I'm saying? Right? So this is the kind of training you're getting. This is the kind of training you get. If you overlook certain corner, well, that corner is going to give you trouble. Okay. So now the expressions for these two cases, of course, are the same. Sorry, the expressions for these two cases are the same, no difference, right? But in the case of x greater than -2, the absolute value of x plus 2, when x is greater than or equal to -2, that's going to be the same as x plus 2. This is where you kick that in. When x is less than -2, the absolute value of x plus 2 is equal to the opposite of x plus 2. So in your mind, the words that go through your mind are these, or as a reference, or these are just used as reference, right? It doesn't really matter. If you feel more comfortable to think in Spanish, go for it. If you feel more comfortable to think in Japanese, go for it. But the meaning and ideas are the same. Okay. If you feel most comfortable, you think about these in French, German, it really doesn't matter. The meanings are the same. If you look through the textbooks of calculus classes with different languages, you're going to find a lot of familiar stuff you have seen. Okay, because this is a universal language. Okay, so with that said and done, of course, we're not finished. We already have these two branches. But how do we deal with the further simplification? Can we simplify this? Surely the numerator can be factored. Okay, it can be factored into two. One is x plus 3, and the other one is x minus 2. Hold on. Wait. Is it x minus 2 or x plus 2? Did I copy the question wrong? My bad. My bad, guys. My bad. X minus 2. Did I copy the question incorrectly? I did. I copied the question incorrectly. Okay. I'm sorry, guys. I'm making changes. You guys know what's wrong? It was x minus 2. So this is going to be positive 2. This is going to be minus 2. Did I correct everything? not a -2, +2. My bad. Sorry about that. I'm very sorry about that. Well, it's not my previous situation cannot be done. It can be done. It just, there's no reduction. There's no reducing, okay? But here we want to kick in a little bit factoring technique. We want to kick in a little bit factoring technique. All right. You guys with me? So correct it, correct it. If the question is the same as it was before the correction, you're just gonna have a complicated situation, that's all. Okay, it can still be managed, it can still be managed. Okay, so far so good? Is everybody with me? But this is the exact question I copied from calculus text. All right, so with the factoring done, right? And we get lucky this time because the factoring, right? We can reduce the x minus 2. So in the end, this would just be x plus 3. And this piece, x minus 2 and x minus 2 reduce. So you're going to get a negative of x plus 3. So that will be the final form with 2 pieces. And with that 2 pieces, you can go ahead to do your, limit, continuity, and, whatever you need to do in Cal. Okay, which I'm not going to go over that far. I'm not going to go that far. Okay, so that's all I think I would cover for these kind of questions. If you have any question regarding this, you still have me tomorrow. Or then in the future, you will have to ask the other teachers, ask teachers. Farouz has been attending my classes. Farouz is going to continue to be with you guys. Okay. And if you want to do more, right? And there's a 51B there, 51B there, you can try. Okay, so this is the first topics I want to cover, is the application of the absolute value function. Okay, you will find yourself, you need to use these in calculus 1, calculus 2, and you shouldn't be surprised, you might need that too in calculus 3. Okay, it just here and there, they use absolute value functions in its various form, Okay, the next topics I like to cover, is called decomposition. Okay, the word is new. I would say, you probably can say I coined the word, because there are not very many exercises on these topics. Okay, in your notes, it's on page 129 or something like that. Is that 129? No, 105, sorry. It's on page 105. It's on page 105. Even on that page, at the time, I did not use the word decomposition. But now I decided to introduce decomposition. So if there's a decomposition, there must be composition, right? If there's a decomposition, there must be decomposition. So composition and decomposition are 2 opposite operations, right? I have shown you in many cases, right? You have f function, you have a g function, you compose them. That's called composition, compose or composite functions. All of these are the names of composed function. So you from these operations, you can produce from simple functions much more complicated functions. I remember some student, in calculus class, they came back to tell me that the functions in calculus class looks weird. They do, because they are the consequence of composite of different kinds of functions. Okay, so now in this exercise of decomposition, and I call it a basic 43A. Okay, this group of exercise is to decompose, right? So when we are given when we are given F and G, right? We can composite. We can have all kinds of composites, right? You can compose F, compose F, compose F, compose G. You can do that, right? But what is decompose? So sometimes you're given the consequence of, a lot of functions together, right? Take this for example. I'm taking this calculus class from my bookcase, right? I'm going to pick a question in chain rule, the chapter of chain rule, right? And that should be in chapter 3. That is in chapter 3. Chain rule 3.4 in calculus 1, calc 1, right? You have a function that it's already composed, okay, such as this one. Okay, you have a cosine, square root, sine, tan, pi x. Okay, that's one of the homework exercises you might encounter in your calculus class. So in order to perform the chain rule properly, you have to know how to decompose it. But unfortunately, this kind of exercise, there are not a lot of exercise given in pre-calculus preparation, okay? And so when I saw this problem after teaching calculus many times, and I decided I'm going to make some questions in this direction because students really struggled with chain rule, with the application of chain rule to take a derivative of such an implicit derivative and so on and so forth. So that's where the decompose that word, I introduced. Even at the time I was writing these exercises, and I didn't use this word decompose, but now I think I'm going to use the decompose because we've been doing composing so much. Okay, so with that said and done, so when I'm making these questions, what has inspired me to do this? Number one, because the hardship I saw in my past students. Number two is that once you know composing, I feel decomposing can be done in a pre-calculus class, okay? So that's my rationale. So, but where did I select the questions to do the decomposition? Your calculus textbook. All of these questions I put together, right? In 43A and more 43B, they are from your calculus textbook. So I did not create any. I did not create anything new. They're just directly copy and paste. Okay, copy and paste. And I just spent the time to type it. Okay, so these topics may or may not be tested for this course. I don't know, because I'm not going to prepare your final exam or your quizzes. These may not be tested, but if I prepare your exams, I probably will test you, right? But now someone else will be teaching the class. They may or may not test you, but you must make sure you know how to do this. Okay, for you, it's like earning 10 points, 20 points more when you are in calculus. You got it? So I'm going to cover this piece today. If you need help, and Farouz is here, I think Farouz got it. And your other teacher can also help you, but it just give you like a head start. Okay, so with that said and done, what is decompose? What is decomposition? We'll come back to this question after we have done some simple ones, after we've done simple ones. Okay, so what is decomposing? Okay, I will take the first example. This is my first one. Okay, the first one is right here. I'm gonna just copy from that 43A. Okay, so this function, you can introduce f of x, or you don't have to. Really, it's not a big deal. Let's not to introduce it. Just take this question, right? How do you decompose it? So what we need to do, the process of decomposing basically is to identify identify G such that, okay, F composite G is going to be the function you have at hand. And we want F and G to be simple and better yet basic functions. Because for those basic simple functions, we know how to find the derivative. We have formula. Okay, of course, in this class, we're not going to take a derivative. Okay, you got it? So our job, I'm going to show you a couple examples, right? In this case, I'm going to, you see, when we compose, we talk about, we go from inside, outside. We go from inside out, right? When we decompose, what do you think we should be doing? We're going from outside, inside. Okay? So now, for example, I will take this one, right? And I consider this piece, right, as omega. And then I look at it, the √3 of omega. Hey, that can be a simple function, right? F of x is equals to cubic root of x. So there you go. Okay. And then my G. So from outside, go inside. So that's my G. And I can check. I can test drive it. So I'm going to go from inside out to see if I will get the function, because I want to make sure this is true. Okay, so I'm going to try that. F composite G, right, of x. So F of G of x, so G of x is 1 plus 4x. Right? F of G of x is, from inside outside, from inside to outside. And F function is a √3 function, right? So that's going to be √3 of 1 plus 4x. So if you checked, you can compose it correctly to get the final answer as it was given, then you got it right. And that's decomposition. That's a decomposition. Okay, that's a decomposition. So I'm going to do another example. The other example I'm going to do with you is number 3. Tangent of pi x. This function looks simple enough, but not simple enough to apply chain rule. So you need to have a decomposition process, right? So how would I decompose it, right? So I'm going to see pi times x, and I see tangent. So I see pi times x as a one single variable. Okay, so my f is going to be tangent of x, right? My g is going to be pi x. So that's how I decompose it. And then I'm going to check. I'm also going to check. So could you guys compose and checking this step this time? You have to work this out with your paper pencil. Otherwise, it's very difficult to follow. It's very difficult to follow. You have to do it. You have to do it. You have to do it yourself. Okay, I'm only showing you. You have to do the work. You have to do the work. Otherwise, you're going to have the hardest time in calculus, the chain rule, and the following sections. Okay, not only chain rule. Okay, because after chain rule, you have the implicit differentiation and all of those stuff. And if even at the calculus 2, you still have from time to time, you need to deal with these kind of situations, you know, integration by parts, integration by substitution. You need this. You need this desperately. Definitively. So you need to have that visual. You need to have that idea of decomposition. So when you compose, you go from inside out. When we decompose, we go from outside in. How about we take a break? Okay, I'm not going to give you 10 minutes, right? I'm not going to give you 10 minutes. I'm going to give you until 12:30. This has been too long. Actually, I thought of giving you a break about 10 minutes ago. And I think you need a break, right? This is a lot of information, a lot of exercise required. And so I'm going to give you a break. So we have until 12:30. Okay, so back at 12:30. So I will see you soon. Okay, at the same time, you can, if you want to practice with other examples, and go for it. But I'm just going to give you guys a break and you do whatever you want, okay? And come back and resume the recording. I might be going a little faster here. If you have any questions, please don't hesitate to ask me. But I'll try to be as thorough as possible. So you in the future, when you have similar questions, if I'm not around, feel free to ask your other teacher or whoever that you can get help. But anyway, so when we compose it, right, you at the beginning you're doing decomposing, you want to be able to check to see if you get it right? So g of x here is pi x, pi times x. And then you plug in the function tangent, so you get tangent pi x. Okay. Anyway, so this is how we decompose. In your calculus class, you need to be able to identify these functions almost immediately. Okay. So you will not have, usually your teacher may not have time to go through the training of decomposing. And it's just something you want to be, if you want to be better prepared for your next class, and this is something you want to do. Okay. And next, I'm going to pick up 2 questions from the exercise. Okay, you can see the difference of order. Number 8 and number 9. Number 8 is a cosine x squared. And the other one is cosine square x. Right? Are they the same? Absolutely not. They are not the same. And the decomposition will be totally different, right? Now, cosine x squared, what does that mean? Right? If you see it from functions perspective, right? You have input, and the input is squared. And then the squared x is going to be given to the function cosine x. Cosine. So you get, that's how you get cosine squared, cosine x squared. Okay, how about the other one? Well, the other one means, okay, means cosine x multiply itself. You see how different it is? This one is a cosine x times x. You see how different they are? You see how different they are? They're completely different. For tangent squared, cotangent squared, sine squared is similar. They're all similar. So with that said and done, how do we compose it? The f we have here would be just cosine x. And the g is going to be x squared for the first one. Okay, the next one for cosine square x, right? You have to realize cosine x times cosine x is a cosine x squared. Okay, so these two are the same. You guys see that? These two are the same. So your f function is x squared. Your g function is a cosine x. You see, it's a difference of night and day. The difference of night and day. If you look at the function process, right? If you look at the function process, right? Similar to you know, if you look at the flow, right? You're gonna apply the cosine function. You're gonna get a cosine x, right? It comes out as a cosine x. And then you take that cosine x, you square it. You square the output. How different is that? Right? Very, very different. Okay, so next, I have given you the answer. I've given you the answer, but I want you guys to do the composing. I want you guys to check. Okay, if you can be good at composing function, it will help you to decompose the function. Trust me, okay? If you practice enough, remember we have composing functions way back, you know, weeks back, right? If you can do more exercise to compose, right? And here you get to practice with functions other than just polynomials and roots. You have, you know, cosine, sine function, natural log, common log, and those kind of functions. If you can be good at composing functions, it will help you to decompose. And you need to do both. You need to do both. So please check. Okay, I have composite G here for this one. And I also want you guys to do this one. And we shall have a breakout room, shall we, Bruce?
We can.
Yeah, let's do the composing, okay? So just to check if we have decomposed correctly, okay? So the breakout rooms are open, okay? So feel free. If you finish these, go to do other exercise in this section, and otherwise, and after you know, I think I'm gonna, you know, I'm gonna manage my time so that we can accomplish a bit more. Okay, we're gonna move on from here. Okay, so get this done, get this over. Okay, composing, decomposing. For those of you who stay with me, what you like to do is that you're gonna compose, and then you look back at the process. You look back at the process, and you start to understand, the different ways of composing could have different consequences. Is it raining in your part of town?
Yeah, it's raining. Professor,
Yes,
I had a question. Will the lecture be recorded?
it is recorded.
Okay, because I have to leave soon.
Oh yeah, of course, it's recorded.
Okay, thank you.
No problem. But if you drive, be careful. The road will be slippery.
Thank you.
Yeah, I will need to drive to the hospital today. I'm gonna have my hospital visit today. Okay. How's it going?
Professor, you are muted.
Oh my God, did I mute myself? Sorry about that.
We are good now.
I'm sorry. Okay, so let's go back. So this is the part that we check if we got the right decomposition, because it's very important that you get the right decomposition, and then you can proceed with your calculus steps, right? Now, with all is said and done, I think you guys should be able to do the rest of them, right? I'm going to take an example for number 7, right? You probably haven't done similar questions because in your earlier experience, most likely you just did some linear, you did some, you did some of those linear function, quadratic function, maximum, right? But anyway, so when we decompose, you just go from outside inside, right? The first function you see from outside is ln, right? So ln is a simple function if you see this as omega, right? And that will be your first function. Your first function is going to be ln x. And now let's look at omega. What is omega? Omega is x squared minus 2x, and that's going to be your g. That's as easy as doing that. That's how you decompose. You follow me? That's how we decompose. So decompose in a way is actually pretty straightforward. It's actually straightforward, but you have to know how you get from outside inside. Okay, so let's go back to that complicated situation I gave you there, right? This function. How do I decompose this guy, right? How do I decompose this guy, right? There are many layers in this case. There are many layers, okay? So decompose that guy. Right? How do I do it? Well, from outside inside, right? From outside inside. From outside, what is the function the outside the most? Cosine. So my first function would be f of x equals to cosine x. Right? So I imagine this guy is what? Is my omega. And my omega is that. You follow me? Now, the next layer, what is the function from the outside? Well, a square root of something. And then something is complicated, so I'm going to call it triangle, whatever you call it, really doesn't matter, right? So that will give you the next function, g. And g is going to be the square root of x. You can see cosine x is a function in our basic 1 table. Root x function is in our basic table, right? But what is our triangle? What is our triangle? Our triangle is that guy, right? All right. So our triangle, the triangle from outside, what do you see? You see sine. So this guy is a mess, right? So I'm going to call it collectively, whatever you call it, spade. And my spade, and of course, is this guy, tangent pi x, right? But here, I will be introducing some new functions. H of x, I will call it sine of x, right? Sine x. So you do this layer by layer from outside inside until you get the simplest possible functions where, you can easily find, in calculus class, a derivative of it. Okay, now keep going. And the spade, right, is equal to tangent something. And that something is not simple enough. So I'm going to call that something what? Maybe heart, right? It doesn't matter. And the heart now is my pi times x. So my next function, if I call it k of x, is going to be tangent x. And my last function, I can call it u of x. It doesn't matter what name you use, really. It's finally pi x. So you have well, how many layers do we have? So the composition this time will be how we compose it. F composite G, composite H, composite K, composite U of x. That much of composition. That much of composition. How many layers? 1, 2, 3, 4, 5, 5 layers. 5 layers. And you, when you're in calculus class, from the chapter of chain rule, and you will need to know how to peel it layer by layer. Layer by layer. Okay. Do you guys want to compose this? Do you guys want to compose this? You ready to do it? Are you ready? Okay, I'm going to do the composition for you. If you need more practice, feel free to come back to this recording and practice. Okay, so I will be having F, right? So we're going to have F composite G, composite H, composite K, composite U of X. Okay. From inside out, right? So from inside out, layer by layer, U of x is pi x. So pi x, U of x is pi x. So K of pi x, right? So you'll be working with K of pi x. If K of x is such, K of pi x, right? Pi x is the input. So when this is become pi times x, and over here will be pi times x, right? So K of pi x will be replaced by tangent pi x from inside out, another layer, okay? Next layer. What is h of tangent x? Right, so we have f of g of h of tangent. What is h? H is sine, right? So h of x is right here. So when you have h of tangent, when you have h of tangent pi x, so when tangent pi x is the input, and this will be replaced by the input. And there you go. So your h of tangent pi x is going to be sine of that guy. You see the layers of work to produce those complicated functions. Okay, so over here you have f of g. Now you have a g of sine of tangent. So the input is this guy for g. Okay, the input is this guy for g. So this is a g of x. I'm going to put it right here for your convenience. Okay, I don't want to cram together, right? So g of sine, right? G of sine. So this is the input in the place of x, right? On the other side will be the square root of the input, because the g function tells you whatever input you give me, take a square root of it. Now this is the input. So that's going to be going there. So G of sine of tangent pi x is going to be this guy. Last but not least, we get to apply F. Okay, this is our F. This is our F. Okay, F says whatever input, just apply cosine to that input. Okay, so when we do F of this guy, so F of this input, which is in square root, whatever in the input, and we're going to apply the cosine of that input. Did we get that function we have started with? Yes. Okay. So this process, you must understand, right, is peeling from outside inside. Decomposition. Okay. I hope these are enough examples. If you have any questions, feel free to get back to me. I will still be teaching tomorrow. Okay. And you have homework on these? But do take your time. Do spend some time on this, okay? To ease your pressure in calculus classes. Do you have any question now? Do you have any question now?
Could you scroll down? Yeah, thank you.
One is inside out to compose, and the other one is decompose from outside in. From outside in. Okay, soon enough, you will do this automatically. Trust me, you'll be doing this automatically. Okay, just layers and layers of the decomposition as you do the chain rule. Okay, as you do the chain rule. And of course, if you have any questions, don't hesitate to ask me anytime. Otherwise, I'm going to take you guys to another topics, solving inequalities. Okay, solving inequalities. These are the topics I have selected, which I think is very, very useful and will be very, very useful for you. And in your notes, this titled as solving inequalities. Okay, solving inequalities. Basic 9. Basic 9. Okay. And I will be covering basic 9 and basic 10 together. And I think I should have a comprehensive coverage of these materials by the end of tomorrow. Okay. And once again, the important I want to address here is the understanding. Okay. Remember we have two. We have 6 mathematical principles, right? The last 2, we haven't quite used the last 2. The last 2 is related to, okay, you guys find your flashcard, find these 2 mathematical principles. Okay, number 5 and number 6, right? And they have an important role to play because I want to build a connection. Between solving inequalities and those 2 mathematical principles. Okay, so mathematical principles CI, okay, number 5 and number 6. Okay, I want to build a connection between, as we learn how to solve these inequalities. Okay, so I'm going to give you two perspectives. The first perspective is look at the principles. Okay, so the way I teach it is still is slightly different from the popular method these days from textbook, but I hope I give you a more intuitive, a more visual idea about how these questions can be resolved. Okay, so start with the first one. Okay, basic 9. Basic 9. The title of this question, of course, is called Solve Inequalities. Solve inequalities, and they're nonlinear. They're nonlinear, right? For linear inequalities, you have, you know, you can solve it, right? For nonlinear, how do we solve it? How do we solve it? Okay, so here's the first one: x plus 2 times x minus 3 less than 0. First, we want to review the meaning. First of all, it is an if statement. If is negative, okay, less than 0, I want you guys to think is negative, because less than 0 means negative, right? And find all possible values for x. Okay, finding solutions. That's the meaning. Secondly, okay, let's dig a little deeper. Let's dig a little deeper. How do you view these two? How do you view these two? I view these two as if the product, I see this as a product of two numbers. The product of two numbers. One is x plus 2. And the other is x minus 3. If the product of two numbers, x plus 2 and x minus 3, is negative. So in my eyes, right, I see this as the product of two numbers. In other words, in my eyes, I see this as one quantity multiply another quantity is negative. And find all possible solutions. Find all possible solutions. Now I want you guys to take a second look of the basic principle, mathematical principle number 6. Principle number 6 is saying what? If the product of two numbers is, right, positive or negative, you know, all those cases being addressed, right? So this is the perspective I want you guys to see. Okay, you see this as a product of two numbers. Okay, so we see this as a product of two numbers. So A times B is negative. The product is negative. So what can you say about these two numbers, right? So we try to figure out. Principle number 6 also tell us, right? If we multiply a positive number with a negative number, we are going to have a negative product. If we multiply a negative number with a negative number, we're going to get a positive, right? So these are completely common sense to us. But how do we design this principle into solving a question like this. So the issues here is not, we probably will have more solutions than we expected, right? You're not going to have x equals to something. You're going to have, a lot of solutions. We're going to have a lot of solutions. But how do we approach this? Because the sign of the sign of the two numbers, okay, the sign of the two numbers determines the product, whether the product is positive or negative, right? Let me say it again. The signs of the two numbers, okay, let me put a plural, because the sign of the two numbers could be the same, could be different, could be one is a positive, the other one is the negative, vice versa, depending on the situation, right? The sign of the two numbers are essential in solving these questions. So we are going to observe the sign of these two numbers. But these two numbers, we don't know. We don't know these two numbers, right? So how do we observe these two quantities we don't know? We have to consider all the possibilities, right? We have to consider all the possibilities. So now with this in mind, right? With this in mind, we will consider, okay? So think out aloud. We want to see how x plus 2 behave in terms of sign. Okay, we want to see how x plus 2 behave when signs are considered. In other words, one is x plus 2 positive, one is x plus 2 negative, one is x plus 2 0, right? We want to observe the signs of x plus 2. Okay, we want to observe the sign of x plus 2. Is it when it is positive, i.e. when it is positive, negative, or 0. When it is positive, when it is negative, when it is 0. Among all three situations, right? What is the easiest to tell? In other words, when is x plus 2 0? When is x plus 2 0? All you have to do is just set x plus 2 equals 0, right? And you solve that, what you get? You get x equals to -2, right? So this tells us when x equals to -2, x plus 2 is what? Is 0, right? But x plus 2 is defined on the entire number line, right? If you look at x plus 2, the domain is all real numbers. The domain is all real numbers. So now we have identified a number that make x plus 2 equal to 0. So what number will make x plus positive? What number will make x plus 2 negative? Once we identify when x plus 2 is 0, that will make it easier to identify when x plus 2 is positive or negative, right? So you'll be asked the question, when x plus 2 is positive, how do you find out? You subtract 2 on both sides, right? So x is larger than -2. Do you guys follow me? So when x plus 2 is negative, and you solve that inequality, you get x less than -2. Do you guys hear me? You guys hear me? Right? So we figure out to summarize these three situations, oops, right? To summarize all three situations, what have we discovered? What have we discovered? If I have a number line, right? I have a number line. And there's a -2 here, right? And of course, on the number line, you have 0, you have lots of numbers. But in terms of the sign of x plus 2, in terms of sign of x plus 2, right? X plus 2 at -2 is going to be 0. Right? 0 is a neutral sign. It's neither positive nor negative. It's a neutral. But if I pick a number, if I pick a number from less than -2, if I pick a number less than -2, what will happen? If I pick a number less than -2, x plus 2 will be negative. Do you guys see that? So there will be a bunch of negative sign all over. So when you pick any number arbitrarily, okay, if you pick a number arbitrarily from less than -2, x plus 2 is going to be negative. When we pick a number larger than -2, what will happen? X plus 2 is positive, right? X plus 2 is positive. So here we have lots of positive sign here. And x plus 2 will stay positive on this side, stay negative on this side, and 0, the neutral number. So -2 is the place where x plus 2 changes sign, right? Changes sign. You guys follow me? In other words, if you pick a number arbitrarily, okay, I want you guys to hear my words and think about those words I said. If I pick a number from here and I pick that number, I'm going to plug in x plus 2, it's going to be positive. And they're always going to be positive. So -2 is the point of separating negative from positive. So that's what I found. Do you agree with me? And the graph would look like this. So this graph describes the sign distribution of x plus 2. For any number you give me, I can tell you the sign right away. Do you guys follow me? Do you guys follow me? If you follow me on this idea, we can analyze x minus 3 in similar manner. How about x minus 3? How about x minus 3? In other words, right? How about x minus 3? Okay, so I'm going to ask the question, when it is positive, negative, or 0? Can you tell me now? Can you use a word to describe it? Okay, I will show you how to show your work, but right now, right here, I'm trying to enhance our understanding by why we do it a certain way. Okay. When is x minus 3 positive? When is x minus 3 negative? When is x minus 3 0? So you go through similar process, right? You go through similar process, right? We start from easiest. When is x minus 3 0? When? x minus 3 is 0 when what? When x is 3, right? X minus 3 is positive when what? When x is larger than 3. X minus 3 is negative when x is less than 3. So in similar manner, if I look at my number line, right? If I look at my number line, I have a number 3 here, right? And I also want to know the sign of, this time is not x plus 2, it's x minus 3. Right, x minus 3, the domain is all real numbers, right? But when I pick a number less than 3, x minus 3 is going to be negative because this is what it says, right? So this is going to be negative. Oops. Negative. At 3, when I choose x equals to 3, 3 minus 3 is going to be 0. Right? If I choose a value x larger than 3, then it's going to be positive. I see something on the chat. Okay. You guys have any questions? Once we have this analysis, the entire sign distribution for x minus 3 is complete. Because once you give me a number, I can tell where it is positive, where it's negative. If it falls in less than 3, then it's negative. If it's larger than 3, it's going to be positive. If it is 3, it's going to be 0. So with these two pieces of information, hold on, I'm sorry. Okay. With these two pieces of information, okay, I'm going to show you that we will be able to find our solutions. Okay, so I'm going to bring these two with me. Okay, so when we solve this, right, so we know the sign of each product. This is A, right? This is A, and multiply B, right? A times B. A is x plus 2, B is x minus 3. So we know the sign of A and we know the sign of B and how they distribute, right? And finally, you want the product to be negative, right? Because it said if the product is negative, and we want to see on the entire number line, okay, the sign of the product. When is the sign of the product? And how is the sign of product distributed? Once again, I have this number line. Okay. On this number line, I have a -2, which is right here. And I have a +3. Right? So this number line is into 3 pieces. 3 pieces. Look at these 3 pieces. Okay? If I pick a number from here, and I pick this number, the same number plug in x minus 3, the same number plug in x plus 2, what do I get? I'm going to get a negative times negative. Negative times negative, what do I get? What do we get? Negative times negative is a positive, right? Yeah. Are we using principle number 6? Are we using principle number 6? So if we pick a number from smaller than -2, we know that in that case, x plus 2 is going to be negative. X minus 3 is also going to be negative. So we're dealing with a negative number times a negative number, so we are going to get a positive number. If I pick number -2, what will happen? At a -2, x plus 2 is 0. At a -2, x minus 3 is going to be not a 0. I don't care what value is, but the product is going to be 0, right? Because when you multiply two numbers, one of them is 0, the product is going to be 0. Now, if I pick a number from in between, what will happen? If I pick any number between -2 to 3, what will happen? The same number I pick, plugging here is going to be positive. Plugging here is going to be negative. Positive multiply negative, what do we get? Positive times negative, what do we get?
You get negative.
You get negative. So you get, if you pick a number from here, you get negative. Wonderful. What if we pick 3 exactly? If I pick 3, x minus 3 is 0. X minus 3 is 0. If I pick 3, x plus 2 is not going to be 0, but it doesn't matter because 0 times anything is going to be 0. So over here is going to be 0. You guys follow me? So each area I have worked with, now I have one more interval to work with. I'm going to pick a number from here. I'm going to plug in x minus 3 and x plus 2. If I plug in x plus 2, I'm going to get a positive. If I plug in x minus 3, I'm going to get positive. So I'm going to have positive times positive. Positive times positive, what do I get? What do I get? Positive times positive is what? Nobody says anything? It's too trivial. So about this product, now I know this product is going to be positive if x is from smaller than -2, is 0 if x equals to -2, between -2 to 3 is going to be negative, equals to 3 is going to be 0, larger than 3 is going to be positive. And what is the desired statement? If statement. The if statement says if the product is negative, so where could I find the solution to make the product negative? It's between -2 to 3. Do you follow me? Yeah, our time is up. You guys get it? Yes? Yes? So now with that said and done, we can say the solution. What solution? The solution to the product that is negative are what? Are numbers between -2 to 3. So this is one of the method, which is different from the most popular method in recent textbooks. Okay, I decide to be a little bit different, even though in nature these are similar. They all works, because in the textbook, in most of the textbook these days, they teach it by making tables. If you learn it that way, great. Okay, calculus textbook, you also teach it that way. But I feel I give you a more thorough analysis with the nature of the question this way. And tomorrow, I will be talking about another perspective, which is a functions perspective to look at this, solving these inequalities, okay? So I will see you guys tomorrow. Farouz just announced his office time, his time. And I'm happy to report you guys is going to get a teacher who's going to teach live lectures like I do, and you will be in good hands. Okay, so I will see you guys tomorrow, and have a great day.
Thank you, Professor.
Thank you.
Thank you for the lecture, Professor.
Of course. Thank you so much.